Okay, Assalamualaikum and a very good afternoon, everyone. So first and foremost, thank you very much for participating in this event. So for today's session, hopefully everyone will mute their microphone and video. I think it's already automatically blocked for a while. Okay, so for today's event, we will start off with a presentation by myself on ULab, which is UTP, a laboratory management system on how to search for equipment and how to log requests in ULab. And then later on, we will um, proceed with presentation from Ms. Chan Chun Fong from Orbiting Scientific, which is the manager for chromatography application, Orbiting Scientific and Technology. So she will share on the fundamentals and also some of the theory on HPLC. And then at the end of the session, we will post if you have any inquiry at our chat box. So please free to type your question in the chat box during the session. Okay, all right. So without further ado, I will proceed with our laboratory management system. So you can, everyone can have a look on how to use ULab. Okay, hold on. Okay, hope everybody can see my screen. Okay, so this is the interface for our ULab, which is where all the information for laboratory is the website. Okay, and as you can see here, so this is information for final year student. So we have a group, postgraduate, and also for all the projects group. And then here is the DIY or frequently asked question. So students and researcher can refer here for any inquiry regarding the process or and as well as about your grant, how to log the request. So everything is also stated here. Okay, and for external user, meaning the one client from external from UTP. So you can also request for the testing to you can submit to us any inquiry regarding testing. So this is all our systems. So now, okay. So make sure you have a very good internet connection. If not, the loading can be very slow. Okay. So here is how we see which is the subscribe group. So here is the about us, about some of the how to put a sample and then where to submit the sample. So we already stated here, and these are the list of equipment as well as the person in charge of the particular equipment. So this one is the contact number and whatnot for the reference. And this one is regarding equipment availability. So let's say if you have, as you can see here, this one is only the equipment that is under this cluster. And here is on how to log your request. So as you can see here, we have a different type of testing. So you can click and then you can see the image of the equipment as well as the brand. And then you can initiate request. And if for internal staff, if you staff or student, okay, here is the picture actually. If you want to know the pricing, so you can scroll down and you can see the service price list for different type of testing. So like for example, for NMR, you want to do for carbon, 13 carbon, so the internal price is 100. For special rate is for the FYP. So here, everything is displayed here prior to uh, logging the request. So this one is only on the price list. This one is on the type of testing. So different type of equipment. So you can view and search. If you want to see the image, then you can download the image as well, like here. So you can download and put in your report and the model and the brand in your paper or journal if you require. So you can just get the info from here. All right. And this function up here, as you can see, there's a search function. So this one is the purpose if you want to see if there are any equipment, if you're not sure where it is, whether UTP has it or not. So you can just, like this is some of what I searched previously. Okay, so when you search, it will show like here. That means this equipment is available in research center. So here, and then you can click and see the image of the equipment and the description. So this one, this equipment, as it is subjected to approval by the research group, because this one is under ICM. So you have to see when you search, there are certain equipment, like let's say you want to find microwave. Maybe you want just a simple microwave or microwave digester, I don't know. But just if you want to know what are the facilities available. So here we can see that there's a lot of centers that has microwave, but not all are like here. The microwave is like this one, but most probably the one that you want, maybe the synthesis one, like this one. So this is how you get the info for what type of equipment that you wish to use in this platform. Okay. All right. I think that's all from me because this one is only just an introduction on ULab. Okay. And then for today's purpose, as you can see, you want to log the request for HPLC. Okay. So now you can see the equipment availability. So this one is okay, Mr. Jalani, which is the person in charge. So he's also in charge for different type of equipment as well. So these are the image of the equipment. This is how to log the request. As you can see here. And once you initiate the request, you have to this is just an example. Oh, it's okay. All right. So you can see the form where there are info that you need to put into the form. So you have to put your sample, the sample name according to your label, the description, as well as what type of detector that you wish to use. So as you can see here, there's a drop down. We have UV, we have visible, we have UVVs, as well as RI, which is refractive index. And let's say you have 3 samples. So you just click here, 3 sample, you fill up the form, and then you just add selected service. And then, like here, the one with asterisk, you have to put what type of mobile paste, flow rate, as well as what the detector that you wish to use as well. And this one is regarding the method, because in case Mr. Jalani needs to further discuss back whether we can do it or not. So if you have some reference that you follow the procedure, so we can refer as well. So you can just upload together here. And this one is regarding the sample testing. Once we completed the testing, students are required to collect back the sample. So this one is just to acknowledge that you are aware that you have to collect after the completion of the date of the testing. So this is how to log the request for HPLC, as well as how to search equipment. All right. Okay. So without further ado, now I would like to inform. I would like to invite. Sorry, I would like to invite Ms. Chung Fong to share her presentation on how to avoid common pitfalls in HPLC.
Okay, yeah. So I will start my sharing today. So yeah, first of all, I'd like to thank Puan Naim for inviting us to be here with all of you, and thank you very much to everyone for your time to attend this today's seminar. So here we would like to actually share with you some information and also the products that are actually from Agilent that can actually help you to avoid or at least reduce those common pitfalls in the HPLC. So yeah, I'm Chun Fong from Operating Scientific. So first of all, please allow me to just briefly introduce my company, Orbiting Scientific and Technologies in Berhad. Yeah, we are the company. We have been in the market since the year 2000, and we are now the authorized distributor for Agilent for their consumables and accessories for their HPLC, GC, spectroscopy meter, and also the sample preparation products. So Orbiting Scientific, yeah, apart from being Agilent's authorized distributor, we are also the appointed distributors for a wide range of the advanced scientific instruments in Malaysia, like mercury analyzers from NIC Japan, and also a lot other more small equipments like grinding machines from Powtech, and yeah, a lot. So here we serve government laboratories, commercial testing laboratories, research institutions, university like UTP, and our customers are from all over Malaysia. Like Petronas is also one of our main customers, Shell, and also Sandapi, and many other MNC industries. So today I would like to share those HPLC accessories and consumables by Agilent. Let's start with this, the instrumentation of the LC. In here, so because a lot of, all of you here are the LC users, so just maybe make a brief revision on this LC system. So in the LC's instrumentation, normally we'll see, there's on top of that we have a mobile phase reservoir, and it will come with the module, the pump module. And in the pump module, there will be the mixer and also the degasser. So this pump module always we have those like a quaternary pump or binary pump. So the function of the pump is actually to force the mobile phase through the LC at a specific flow rate. Usually we use it at 1 to 2 ml per minute range. And then the next to it will be the auto sampler or the injection port, where we will introduce the sample, the liquid sample, into the flow stream of the mobile phase. And usually we'll introduce 5 to 20 microliters of the samples. And the next of it is actually the column and oven module. So column, always we say it is the heart of the system, because without the column, chromatography will not happen. So it is used to separate the sample components. But inside the column, there is actually the small particles, means that there's a packing material inside the column. And this packing material, in fact, the cause of the high back pressure of at the normal flow rate. So therefore, we need a pump to push hard to move the mobile phase through the column. Yeah, and this resistance, we actually call it as a pressure. Always when we run the HPLC system, we want to actually know the column pressure and also the system pressure. Then after the column, the analyte will go to the detector, and we need a detector so that the analyte that eluted out from the column can be detected, and the detector will give an output onto the recorder or computer, and we call the result as a chromatogram. So let's look at it. Please allow me to just spread this LC system into a schematic diagram. Very basic, a very rough one. Okay. So for this, this is a mobile phase. Usually the HPLC will start from the mobile phase reservoir, and the pump will draw the solvents or the mobile phase and get the mixing in here, and it will go through the auto sampler and injection port, and next to the LC columns and detector. Okay, so here let's see how the thing works. Very small, very basic in animation of this LC system. So the pump will draw the mobile phase and then mix it, and then it will pump through the injection port, LC columns, and next after detector, it will go to the waste. So throughout the LC program, they will keep pumping the solvents through the column. Then in here, we will introduce a sample, okay, by using a syringe at the injection port, and the mobile phase will push the sample into the column. And remember, the mobile phase actually keep moving or keep pushing through the column. Therefore, the analyte will actually following the mobile phase, traveling through the column. So when you travel along the column, the analyte of the samples will have a different interaction with the packing material inside the column, and it will get separated. So the less retain or the less affinity compound will actually come out first and go to the detector and give you a peak. Then follow with the second compound, and you get a second peak. And the strongly retained compound or highly retained compound that will come out last and will give you another peak. So this diagram, we call it as a chromatogram. Yeah. So a few things that when we do the LC analysis, actually, when we use the LC system, there are a few little things that we actually need to take note of. The first thing is actually, in fact, we need to avoid the air bubbles, because the air bubble can be catastrophic to our column chromatography, because it will block the sample from flowing through the column, and also actually it will give you a lot of the funny we call it funny chromatogram. So air bubble is actually one thing we want to avoid. And then the second thing is actually we want to eliminate the particles, because the particles can come from everywhere in the flow path. It can be from the solvents, it can be from the samples, or from the wear and tear of the instruments parts. Then all these are particles, because remember that the solvents, the mobile phase will pass through the column. So it will actually tend to accumulate at the column side and cause the high back pressure and damage the LC column. And the next thing is actually the leaking. Okay, we can see that actually the LC system is we call it is a modular system. Means that we have a pump, we have the injection port, we have the LC column with the detector. All these are connected via tubings. So, and because of the high pressure on the column, we need a high pressure pump. And all this actually this high pressure require us to have a very good connection, especially at the column. Otherwise, it will actually cause leaking. So leaking is another things that we need to actually watch out for during our LC analysis. So now I would like to actually just share with you. Actually, there are a lot of the products that we can actually use to help us to improve our LC chromatography efficiency, or to prevent any pitfalls in the LC analysis. So please let me go through with you from part by part. Okay, so first is actually in the mobile phase in the HPLC solvents. So filtration is always we need to do. So for the mobile phase, we need to actually filter it. So inside here, we will actually, this is the mobile phase filtration device, okay? Then in between, we will actually put a membrane. Then the mobile phase will be poured into here, and we will actually connect this device onto a pump. Then this one can actually do the filtration, the first layer of filtration to eliminate the particulates from the solvents. Yeah, the next thing is actually we will contain the solvent in the solvent bottles. So there are many types of the solvent bottles. Of course, mainly we have clear glass and also the amber. Use the amber glass to avoid the algae growth. Okay. Then the next thing is actually the inlet filters. Always check our inlet filters at this mobile phase reservoir. So this is another layer of the we call it guard house, another level of guard house to prevent the particulates from entering the LC system. Okay, so here just to share with you some information about the care for mobile phase. So if possible, we want to use the sterile solvent bottles to actually to avoid the microbial growth. Yeah, and then filter the mobile phase through filters, and then replace the solvents every 2 days or refilter it before you use it. it's just like especially if you're using a mobile phone with a buffer. So buffer, it is actually, we always recommend to prepare it freshly every day. Yeah, because the buffer can affect the separation very much. Yeah, so the next thing is actually we want to avoid the exposure to the direct sunlight. You can use aluminum foil to wrap up the bottle, or use a brown or amber glass bottles. Yes. So if you filter a large quantity of mobile phase, and maybe you are not using it or finish it in within a day or 2 days, yeah, so you can consider adding 0.1 or 1 millimolar of the sodium azide, or 5% of organic, 5 to 10% of organic to the aqueous mobile phase. So this one can actually help in inhibiting the microbial growth. Okay. So the next thing is actually about this, we call it the capping of the mobile phase. Yeah, maybe some of the lab, yeah, they will actually just leave the mobile phase bottle open, and then they just close it with aluminum foil, or maybe paraffin. So in fact, a good closure is actually very important, because the mobile phase that we use usually are organic, and like some of them are carcinogenic, such as acetonitrile is carcinogenic. And also some of them, they may need to add in like TFA, which is very smelly. Okay, so all this, if let's say we didn't close this mobile phase bottle properly, they will eventually vaporize, and the vapor will go into our laboratory environment. So this is not good to our health. This is first point. But the second important point in here is especially for those, if you are using a pre-mixed mobile phase, means that you are using like maybe for 60% methanol to 40% water. Okay, so if you just you pre-mix it into the, maybe you will pre-mix it into the bottle before you go into the LC system, right? So if let's say you leave it open, you leave the cap open, and then maybe on the first week you didn't finish the mobile phase, then the next week you come back and you use back the same bottle of this mobile phase, you may find that your separation, your chromatogram change. Yeah, why is it? Have you ever think about that issue? Okay, it's because methanol has a higher evaporation rate compared to water. Water is hardly evaporate, right? So overnight or over the weekend, because of the Malaysian temperature, I mean the weather, so the hot environment will cause the methanol to evaporate faster. Then the ratio, the percentage of the methanol against the water will become different. Then you will affect your separation. So capping the solvent reservoir is actually very important for these two reasons. Okay. So the next part is actually in our connection, in our the flow line. Okay. So here, apart from filtering the mobile phase and also having the solvent filter inside this reservoir, in fact, it is good that if you can actually install another layer of this filter, yeah, especially after the injection port. Okay, so this one can prevent the particulates from entering the HPLC column. Yeah, so as mentioned in the early part of the slides, that the particulates, in fact, actually it can spoil our column, it can damage our column, or make our column have a shorter lifetime. So this Agilent have this Infinity Lab solvent filtration, the quick change inline filter that can help us to actually to enhance the filtering process. So the next is actually about the sample. So yeah, understand from Puan Naim and also the Mr. Zailani previously. Yeah, they will receive the samples from you all. Yeah, so the sample is actually, I mean, we require it to be filtered before we inject it into the LC system. Yeah, so here the choice of stream filter is another thing that we need to take note of, because in stream filter, basically there are two types of stream filter. the pore size, 0.2 micron and 0.45 micron. So it depends on the columns and also the LC system that you are using. If you are using a HPLC system or the column which is a sub 2 micron particle size, so it is actually advisable that we use a 0.2 micron pore size of the strange filter. Yeah, so for other common filtration, you can use a 0.45 micron strange filters. Also, there are many types of strange filters such as a nylon, PTFE, PVDF, regenerate cellulose, all those things. So here we have a guideline on how you want to select the membrane. So it depends on the solvent compatibility. Yes. So overall, PTFE may be a good membrane that we can choose because it is compatible to most of the type of the solvents. However, you have to know that whether it is a hydrophilic or hydrophobic. If it is a hydrophilic type of the PTFE, you need to pre-wet it before you filter your samples. Otherwise, you will have a problem in pushing the sample through. Okay, because you need to pre-wet it. Otherwise, it cannot accept the aqueous phase. Okay. Yeah. So the next thing is files. Yes. So the files, actually, there are also many types of files. We have the clear glass, we have the amber glass. It depends on the sample that you're containing, because if let's say your sample is light sensitive, of course, you need to use the amber glass vials. Okay. And then also there are many types of the caps that you can select. Usually for LC, we use a screw cap and then with the pre-slit septa. Okay, so you can look at this diagram. So the files, the cap, and on the cap there is a septa. Okay, so the choice of septa also depends on your analysis. So for LC, we use pre-slit septa, and then also there are septa materials like PTFE, silicon PTFE, or just 2-layer PTFE silicon. Okay, so for those analysis, let's say your analysis is actually very sensitive to this selenin or selenol group, then you have to use the PTFE selenol, silicon PTFE. Means that is a sandwich by the silicon is sandwiched by the PTFE, so there won't be any selenin issue in your analysis. Okay. So for sample filtration, it is actually there is another type of product you can consider. Initially, you can see that you need to use a syringe to draw your sample and then push it through the syringe filter and then into the files. So here, Agilent, they come up with a product called Agilent Captiva filter files, which you just need one type of the product rather than 3 products in here. So what you need to do is just to introduce a sample into the vials and then push the filter, the insert through it, because under this insert there is a membrane. The membrane will actually capture the particles under here. Then after filtering, you just put the whole vial into the auto sample and it's ready for analysis. So after the sample part, we come to the connection. It is especially important at the column connections. So for those who actually who has experience in changing the column, maybe you actually can recall, yeah, because I mean from the field visit, we saw customer. Okay, of course, the common or the standard column installation is we need to use a wrench, okay, to lock the column, because this one is a high pressure connections. So, but then if we didn't connect it properly or we didn't lock it properly, leaking will happen. But we also very scared that we may be over tighten it. And also another thing is actually the connection. So you can look at this first diagram. If our tubing is pushed into the column, it will leave a space in here. So here will cause a leaking. Okay, but if let's say our tubing, we didn't push it into it nicely, you leave a space in between the tubing and the column inlet. Then in here, you will create a missing chamber. So at the end, what you will get is actually a very poor chromatogram with the pigtail links. Okay, so a good connection should look like this. Means that the tubing are sit nicely right in front of the inlet of the column. Okay, and then there is no other space, and all are well fitted into the column connection. So here, if you always need to change the column, it is good that if you can consider a quick connect and quick turn fitting, which it doesn't require any tool. What you need to do is just turn this blue screw to hand tight, and then just press this handle. Then you can actually create a very good zero depth volume connections. Okay, so next time when you see a chromatogram in this way, maybe you have to check whether you have these back connections on your columns. So the next slide is about the HPLC columns. So this is a schematic diagram of a HPLC, the internal. So inside, there are actually a lot, there are packing material inside, and which of it, the common HPLC column, the basic of it is actually a silica. Then it is coated with a stationary phase. So usually, maybe most of you may be using a C18 column. Okay, so here, would like to actually share with you what are the things that we need to consider when choosing a column. Of course, based on your sample type, and then whether the sample require a high pH or it is ionizable, and also whether it is a macromolecule or it is a micromolecule. Okay, so from knowing the sample property, we can choose a column according to the column specification. So the column, there are many types of columns available in the market nowadays. Yeah, so the common, or we call it the most common or conventional one would be those totally porous particles. So for this type of the totally porous particles, the analyte will have to travel through the particles and out. So it have a longer diffusion path. And nowadays also, actually the technology getting advanced, more and more advanced. So there are a lot of we call it superficially porous particles technology available in the market from different manufacturers. So what it does is actually they insert a solid core in the particles. Then when you introduce a sample, the analyte traveling through the column, the analyte will actually have a shorter diffusion path. So from here we can see the same amount of analyte that traveling through these two different columns. For the totally porous particles, you will have a wider peak, while for the superficially porous particle column, you will have a sharper peak. So the sharper the peak it is, the easier for you to analyze the chromatogram. Yes. So the next choice, or the next things to consider when selecting a column, in fact, is actually the surface chemistry, because the surface chemistry can affect our selectivity, the separation selectivity, and then also it ties down to the bonding density and cellulose group. Okay, so which I will show you later what type of the surface chemistry available nowadays in the market. Okay, the next is, of course, if you can choose a good column packing technology, then you can, for those column, a high quality column, it should have a better column lifetime. And of course, each column should come with a certificate of analysis. Okay. Yeah. So this is one of the example of the different type of we call it phases available for the HPLC column. So like C18 is a commonly used column, and also some of the manufacturers, they have a C18 column for the high pH application or low pH, extreme low pH applications. And apart from the C18 or C8, actually we can have we call it reverse, we call it RPMide, or the pentafluorophenol phase, or the phenyl hexyl phase, or the aqueous phase, and also cyano group. So there are many types of the column phases available. Sometimes when we do some separations, we change different brand of column of a C18 columns, it still didn't give you a good separation. Maybe it's time for you to consider other phase of column rather than C18. Okay. So here, maybe later you can actually go to the website and you can actually type in this part number, which you get we call it this column selection guide. So they will tell you what are the applications that can use for each type of the faces. Okay, so from C18 to Final Hassel or to those chiral columns. So from Agilent, we have basically we have this polar shell range of a column, which is the superficially porous particles, and also we have a Zorbex family for wide range of selections. Okay. So the next, after the column, we come to the detector. So detector-wise, there are many types of detectors, but of course depends on your analysis as well. So UV-Vis or DAD or PDA detector is the most commonly used detectors in HPLC. Yeah, so most of the analytes can be detected here. However, if let's say in the future you actually you will need to analyze samples that does not absorb UV, such as sugar, they don't have a chromophore group. So in this case, a refractive index detector or RI detector is required. Or you can use considering the ELSD, the evaporative light scattering detector. Mass spec is nowadays also getting more and more, we call it common. It is not a detector, however, yeah, it is actually a spectrometer. However, we use it to actually to detect analyze based on their molecular weight. So apart from these few commonly used detectors, there are also like conductivity detector, fluorescence detector, chemiluminescence detector, and a lot more available in the market nowadays. Okay. So the last part after the detector would be this waste. So the whatever they pump into the LC systems through the column to the detector, it will come to the waste. So for waste, yeah, it collect anything, right? Whatever we introduce, it will collect. So it is important that apart from capping our mobile phase, okay, we also must cap our waste can. So here you can actually see that if you can have a carbon filter, then the whatever vapors that released from this waste can be trapped, and it will give you a cleaner air or cleaner laboratory environment. So here is all about the products that can actually help you to actually to do a better LC process. And yeah, so that's all is from my sharing. So in here, in the future, if you have questions or you need a quotation or need to know more about the products, please feel free to contact my colleague, Miss Long. Yeah, she's the product specialist taking care of the UTP. Okay, or you can scan this QR code to actually to contact our sales team, yeah, directly. Okay, so that's all from my side. So thank you very much for your attention.
Okay, thank you, Miss Chung Fong.
Yeah, thank you.
All right. So dia bunyi bergema pula. Okay. Is there any question from the participant? If you'd like to ask, I'm opening the session now. You can raise your hand or either type at the chat box as well.
Yes, just please feel free to just ask if you want to know more or you have questions on during my sharing. Oh, okay. Hui Yong, she asked if there is any clogging happen in the system, such as a high pressure. Means that you detect a high pressure in your system, right? Is there any solvent to flush? Usually in this case, we don't use a solvent to flush. It depends on where is the pressure comes from. So let's say it happened on a column. Yeah, so it's whether you need to, it's time for you to change a column because maybe mostly it's because of the particles has accumulated at the inlet of the column, or the worst come to worst, what you can do, the last thing you can do is actually back flush the column.
Oh, there's another question, Ms. Chung Fong.
Yes. Yeah, so can the HPLC column damage if we keep inverting its position? Yes, it can damage if, let's say, we inverting its position. That's why just mentioned that it is the last solution we want to try. Yeah, so that sometimes the result is not good. So we try to flush inverting the column to see if the result improve. Can the column damage? Yes, it can damage because inside the column, just now, if let's say you see the diagram, right, the column diagram, there are particles. There actually is a packing of particles inside. So if you back flush, actually it will actually cause some may cause some void in the column. So therefore, flushing is a last thing we want to consider. It's a last step we want to, we call it do the reviving of the column. So that's why actually filtering the sample, filtering the mobile phase, a double layer of filtration is actually important to keep the column longer lifespan. The column can damage it, let's say we keep back flushing it. Also, one thing is actually for column, let's say everyone, maybe you use a different column. So after you run your analysis, you actually unplug the column so that you keep it on your own. So it is always remember that you have to cap the column nicely. Both ends have to cap. And before you cap it, of course, you have to flush the column. Especially, let's say you're using the mobile phase with the we call it buffer. So the buffer actually it can precipitate. They will be precipitate on the column. So it is a must to flush the column. So every time when you receive a new column, right, there will be actually a data sheet to show to guide you how to actually maintain a column.
Is there any more question?
Oh yeah, one more thing is actually regarding Miss Nufaha Parahin, we call it the questions. So she say sometimes the result is not good. So the result is actually also depends on is it the peak shape is the chromatogram is become deteriorated, means that the peak has been become broadened or tailing, or it's because of we call it a recovery is poor. So I'm just not sure which the result not good is referring to which issue. So if let's say you see the chromatogram has run a bit, maybe you can actually, there's we call it troubleshooting guide. They'll tell you, okay, let's say your chromatogram has this tailing in this way, so it could be because of this and because of a certain reason. So we can actually troubleshoot from there. So sometimes the problem may not come from the column, but it may come from other places. Any other questions? Yeah, welcome, Miss Farahin.
All right. It's okay, Ms. Chung Fong. If there are any more questions, you guys can just type at the chat box because after this, we will just show a video on the sample preparation. Mr. Jalani, okay, is he here? I think he was here. Okay, because Mr. Jalani, unfortunately, he has an emergency, but he's joining our event as well. But later on, I'll just show the video so everyone can have a look on how the sample preparation is done. Okay. And along the way, if you have any more question, feel free to just type at the chat, and we will go back to that later on. Okay. Thank you once again, Ms. Chung Fong.
Yeah, thank you. Thank you for your time.
All right. Okay, so now I'm sharing the video demonstration by Mr. Jalani. So hold on. Okay. Does anybody have any question regarding the just now? Mr. Jalani demonstrated the Iluan preparation. So that is how for that part, Mr. Jalani is the one that prepares the Iluan, and as well as some of the samples, which is when the students submitted the sample. So those are what Mr. Jalani will transfer or do some of the treatment. So that's why it's very important for the sample that is submitted. If we observe, there is layer, there is like particle. So these are the stuff that we would like to inform the students, the researcher, to please make sure you filter your sample prior to submission, because if not, these are the one that will cause clogging and uh, how to say the reason why some of your peak does not chromatogram doesn't come out as what you expected. So there are a lot of reason. It's either from the sample preparation or maybe the sample itself, because we had cases where when we run our standard, it was okay, the peak was just nice, but when we run the unknown, it was not as per what that is expected. Okay. Any other question regarding the video along the way? Anyone? Mr. Jalani is also in the session as well. He's joining all the way from the hospital. Anyone? Do you have any question? For the time being, I'm also sharing the feedback form. So in case you have any other interest on CAL webinar series, please just let us know. So I hope everyone can see it. So I'm also pasting it at the chat as well. Oh, there's another question. Ms. Chung Fong, would you like to address this question?
Okay. Yeah, it's me regarding Miss No Akila's the questions. If the chromatogram peak didn't separate well or broad, what may be the cause? Is it from the mobile phase, the samples, or the column? Yes, it could be yeah, many reasons, but because we have to actually usually when our customer they have this peak resolution issues, we may need to actually one thing is actually see the chromatogram how, and also to understand how it happened. Is it from the beginning you already didn't get a good separation, or is actually eventually you didn't, I mean the chromatogram peak start broadening? So, and also the mobile face that you use. So I think in this case, it could have to be case by case. So that's why maybe can suggest Miss Akila, you can actually contact liaise with Miss Long, MA Fang, to actually to maybe to please provide us a little bit more information so that we can actually troubleshoot from there.
Okay, everyone can also just click the feedback. So if you have any more question, like I said earlier, so you can just let us know. Mr. Chung Fong, I think another one is also the method itself, right? Because as you said earlier, there's a lot of possibility, right? Why the
Yes.
peak suddenly, maybe the method setting itself or the selection of
Yes.
the supposed detector or whatnot, right? It could be.
Yes.
There's a lot of,
Yeah, it could be
probabilities.
a lot of possibilities. That's why, yeah, we need more information before we can actually tell what is happening.
Yeah, so maybe we wait if anyone still has any question, because I think we're already at the end of our session, because just now we only that's the sample preparation is the one, is the last session. So I think, yeah, we're gonna finish early. So if there are any more questions, please free to ask. If not, maybe I just leave it until around maybe another 10 minutes. Oh, Miss Chung Fong, I think there's no more question anymore.
Yeah, sure, no problem. So maybe
Yeah.
after that, if you all have any questions, can always contact us via email or call Mei Fang.
Okay, all right. Thank you, everybody. I think we've arrived to the end of our session. So thank you so much for joining our session. Okay. I think, I think there's no more question. I think we already addressed all the issues. Okay. Thank you so much, everyone. Assalamualaikum and a very good afternoon. So we've already come to the end of session. Thank you once again for your participation.